Okay, so now we've got some problems that are relating displacement, velocity, acceleration. So we call this kinematics, and we've got an acceleration given here, and we've given a specific number for the acceleration. So that means the acceleration doesn't change. And as soon as we've clocked that acceleration is constant, not changing, we know we can use suvat. So the way to get started on suvat, we launch straight into, we identify it's a suvat method, I must. Okay, and we set it up. So what have we got? So we've got initially going at 12 meters per second. So that's a velocity. The initial velocity is u, so that's 12. The acceleration is 0.4, and it takes 25 seconds. Now always, a diagram can help, but always think about directions because we might need minuses. So it's going at 12 meters per second. I think we have to assume that the acceleration is in that same direction. Okay, I think in an exam question I'd have to make it a little bit clearer because the acceleration could be a backwards one. Remember, acceleration could mean the thing is slowing down. But this question, I think, I'm sure, means us to take that acceleration in the same direction as the 12. So let's have them both as being positive. And we want to know the final velocity. So v is what we're interested in. And in this case, we don't care about s. So we need to quote the suvat equation that relates the four things we've identified, three that we know and one that we want to find. So it's the suvat equation with no s in, and that is the one that is first in the list in the formula book, v equals u plus at. So we write out that equation before we sub in. So even though we are given that equation in the formula book, we've had to select it, and for I must, we want to show a method and a clear statement of a correct equation. Could be getting us a method mark if we try to sub in, even if we sub in wrongly. But we have to write out the equation for that. And v is what I'm finding, so leave that as v, but everything else we can sub in for. So u, we sub in 12, and a, we sub in as 0.4, and t, we sub in as 25. So 12 plus 0.4 times 25 is 10, so that equals 22, but we won't get credit for that because it hasn't got units on. We have to give it its units and its meters per second because it's a velocity. Call that v, and we have terminated properly. That's that one done. Okay, so example 15.2. First thing we need to pick up on are these words constant acceleration, so important. But as soon as we know the acceleration is constant, we know we can do suvat. Okay, so decide what suvat letters we've got. The acceleration is 6 meters per second, so that's A, after 8 seconds. So we're looking for a time interval of 8 seconds, so t is 8. Its displacement from the starting point, that's exactly what s is, so s is 5. And I've got to find the velocity after the 8 seconds, so that's the final velocity. So at the end of the 8 seconds, so I want v. So I'm not interested in u just at the moment, so I'm interested in which suvat equation involves everything except u. And looking down my list, it's this third one down. We don't get to use that very much. So we start with that equation. And the one we're interested in, we're finding v, so that stays as a v, but we sub in for everything else. So s becomes 5, t becomes 8, a becomes 6, and t is 8 again. So we've got 5 equals 8v minus, this works out to 192. And when I solve that for v, v equals 192 added to 5 is 197, if I can spell 7, over 8. Okay, but we're not going to leave it as a fraction. Top-heavy fractions are great in pure maths, but we're expected to use decimals in mechanics, which would give us precisely 24.625. But it's normal to round answers to 3 significant figures in mechanics. So pure maths, we like exact answers. In mechanics, sometimes you get penalised for giving too much accuracy. More on that later. And we must give units. So a rounded answer. But having this more precise one is going to help at the next stage. There are different ways I can do the next stage. And now I'm interested in what u was. And I could go back and work it out from the 5, 6 and the 8, which has got the advantage that I've got a fresh start. If I've done something wrong, I don't get knock-on errors. But the simplest equation to use is the very first one, v equals u plus at. And now I know what v is, so I can use this one here. And if I sub into this one, u remains as u, that's what I'm trying to find. A is 6, t is 8. But when I sub in for v, I must not use the rounded answer. I could use the fraction, or this 24.625, and that's going to give me that u is 24.625 minus this 6 to 8 to 48. So u equals 24.625 minus 48. So I'm going to get a negative answer. Okay, that's allowed. So that means that this has changed direction, which is kind of maybe what we'd expect. This has not got a very big overall displacement. It's had quite a large acceleration over quite a large time. So this is actually changed by velocity quite a lot over this time interval, but not actually ended up travelling with a big displacement, which means there's going to be some negative and positive displacement. So I'm not surprised that u is a negative velocity, meaning it was travelling in the other direction. And if you do this subtraction, you get minus 23.375, which is minus 23.4 meters per second to 3 significant figures. Give it its units, round correctly, and we are done. Which just leaves this last one, which is slightly annoying, because now we are being given speeds in kilometers per hour. We've been given a time in minutes, so the units are already inconsistent. So I could choose to work in convert this 0.5 minutes to hours and work in kilometers and hours, but I'm told that I've got to give an answer in meters per second. So I'm probably going to have to bite the bullet and actually change everything into SI units. And some of the methods we use, especially next year, we just have to be in SI units because the Newton's laws we're going to be using only work in SI units. So that means we're going to have to convert kilometers to meters and hours and minutes to seconds. So how do we do that? Well, 50 kilometers per hour as a speed or velocity means that that rate it would cover 50 kilometers in 1 hour. But I want to be working in meters and seconds, so that would be 50,000 meters in seconds, 60 minutes in an hour, which is 3,600 seconds. So I can now work out the speed or the velocity in meters per second. And I get this fraction 125 over 9 meters per second. Now, if that was a final answer, I'd give it as a decimal. It's about 13.9. But I'm going to be using this not as a final answer, but in future calculations. So I'm going to keep that precise version of it. Okay. All right. So what have I got there? So the context of the question is that its initial speed is at 50 kilometers per hour. So what I've got is a u. If it is suvat, is it suvat? I'm told that it accelerates uniformly, so that means that it is suvat. So I started by doing some unit conversion, but at an early stage I have to spot that the suvat method is what we need, and I've just calculated the initial speed, the initial velocity, so u is 125 over 9. Okay, and then I've got to do the same thing with 80 kilometers per hour, so I can now see the pattern. So 80 kilometers per hour is going to be 80,000 over 3,600, which is going to give me 200 over 9 for v. Now I haven't put the units on that, that's okay, it's not a final answer. Okay, final answers must have units. And the time it takes is 0.5 minutes, which is, I need to work in seconds, so I need to say t equals 30. And now I can use those in suvat in the normal way, so I've got to find the acceleration. So I need the suvat equation that doesn't involve s, and that is the very easiest one, the top one, no s in v equals u plus at. So quote the equation, put in the values of v and u and t from here, and solve for a. So I get 30a is 75 over 9, which cancels, but I'm going to divide it by 30 anyway. My calculator can help with that. And I get 5/18, but it's nicer to give a decimal in mechanics, so that's 0.279. I mean 0.278, and the units are meters per second. That's rounded. It was 0.27 recurring, in fact. And we've got to find the distance travelled during that time to the nearest meter. So now I'm going to be interested in what s is. So I can, I've got a nice simple suvat equation. It's not one of the most common ones we use, but I've got a version of s based on u and v and t. Okay, so on this occasion, I'm not going to use that acceleration. I'm going to use the u, the v and the t that I've got to work out s. So u is 125 over 9, v is 200 over 9, and t is 30, which if I've done the calculation competently is this answer, but once again we would give that in its decimal form. Okay, rounded to 3 significant figures, so it's 500 and 41.6 recurring, so that's 542 meters to 3 significant figures. Okay, and part B started here, and all the work above was part A. So I've labelled up my parts properly. I've got a final answer double underlined and another final answer double underlined, so I am done. So I hope that's clear.